In today's note, we're going to be starting a new unit looking at quadratic relations, and we're going to start off by looking at nonlinear relations. So this is going to be kind of an extension or a continuation on the last unit, as we were dealing with quadratics in the last unit, but now we're going to look at them more graphically. So we're looking at nonlinear relations, and in example 1, we have a rectangle, or we have multiple rectangles where the perimeter is 20 meters. So you don't have this, but we can see an example of the different shapes on the right here where the perimeter would equal 20, and we have a table of values that is completed or at least filled out for each rectangle. So rather than having you go through and cut them out, we have it already kind of filled in here, but you can kind of see an example of what they would look like anyways. So if we have a rectangle with a length of 2 and a width of 8, together they still have a perimeter of 20, right? Because remember, 2 lengths, so 4, 2 widths, 16, add up to 20. But if we want to find the area, remember the area is length times width, so 2 times 8, which equals 16. And the first one was already done for us. Next one, 3 times 7 is 21. And then again, I'm not going to go through and show the multiplication for every single one, but 4 times 6 is 24, 5 times 5 is 25, 6 times 4 is 24, 21, 16, 9, and 0. So that is our table of values completed. And what we can do now is we can graph this relation between the length and the area. So the length is going to be on the bottom and the area is going to be on the side or on the vertical axis. So if I look at a length of 1 and a width of 9, I have an area of 9. So a length of 1, I would have an area of 9. A length of 2, it means 8, so then 16. 3 goes to 21. Then 4 and 24, 5 and 25, and then it kind of repeats on the way back down. And 0. So again, if you're not sure where we got these numbers from, these numbers we are getting from these two columns here. So we have the length and the area. So these two columns here are the ones that we used for that graph. And when we have all the points, we can connect them all together. Oops, wow. So there is our graph of the relationship between a horizontal, the length and the area of our rectangle with a perimeter of 20. So this graph is something different from what we've seen. Normally we've seen straight lines. This one is not. But we can still treat it in the same idea. So for C, if I want to figure out if the length is 2.5, what is the area? Again, remember length is on the bottom in meters, and on the side it's area in meters squared. Again, we're going to do the same type of thing that we would on another graph. You're going to find where the length of 2.5 would be, which would be right about here, 2.5, and you're going to follow this up or draw a line up to where you hit your graph, should be roughly about here, and then trace it over to the other axis, and we have it at, looks to be about 18. So we could say approximately 18 meters squared if the length is 2.5 meters. Let me just move this over. So again, we're just predicting using our graph given one value, and we're trying to look for another. So example 2, I want to graph the relation and then draw the line or the parabola. And the parabola is basically a graph or a U shape, and this is specifically for quadratics, which is what we're going to be looking at in this unit. And a line, we should know what a straight line looks like, and that's linear, right, which we've done at the beginning of the unit and what you looked at last year. So line is linear. So 0 and -3 is our first point. So x is 0, y is -3, x is 1, y is -1, 2 and 1, 3 and 3, and then 4 and 5. And if I want to draw a straight line through this, I can. So I've drawn my line there, and I would say that this is linear. For B, I need to again draw these points. So 0 and 9, so x is 0, y is 9, 1 and 3, 2 and 1, 3 and 3, and then 4 and 9. Zoom in there. So if I draw those, I get this U shape. So this is a parabola. So the relations in example 1, so the one with the rectangle, and this example that we just did, 2b, these are called quadratic relations. And the graph of a quadratic relation is called a parabola. Basically, it just is referring to a U shape. It's symmetrical. That's why you can see that you have points on the same side that are at the same height. And it can look in two ways. One, it can look like it opens up like this, or as we saw in the first example, it could open down like that. So those are the two examples that you may see. So again, this first note or lesson is just introducing the idea of quadratic relations and the shape that the graphs will form when you graph them.